available in your Teams later. I think I can help you find that.
So let everyone know they are being recorded and it's also transcribed. I don't know why the transcription is coming automatically, but that's fine. Okay. Okay, so it's 8:30. We'd like to sort of strictly follow the schedule. And I think there are also some others who have joined us. Okay, so thank you so much for everyone who is joining at this early hour. So shall I open it, Dr. Khan, and then you say something?
Sure, please, yeah.
And then Rhonda says something, and then we will continue with the program, right? I think Dr. Holmes says what about Dr. Sanda comes at 8:45, right?
8:50.
8:50. Okay, so let's officially start this event. So welcome everyone for the Women in Data Science Dallas event 2022, in particular our UT Dallas event. And this is really an extremely prestigious event. The Women in Data Science, the Global Women in Data Science, was started by Stanford University. I believe it was 2016 or 17, but we have been involved since 2018. In fact, I was at Stanford 2018 to give a talk and interview and so on live. And then we hosted it while the Stanford event is going on, or just before we have our event. So we have our event 8:30 to around 11 o'clock Central Time. And then after that, we joined the Stanford event. So we used to have it in person, 18, 19, and 20. And so even Stanford, that was just before the pandemic. And so we would meet in our Texas TI auditorium, and we would have at any time around, around 100 people show up, 50 to 100, maybe, sorry, 70 to 100, maybe slightly less. And it would be a very exciting event. And then we will all watch together the Stanford event. We start at 11 because they used to start their event at 9 o'clock in the morning. But, because of the pandemic, they did not have any event last year. And this year we were supposed to have in person, but in the end they had it virtual. And so we wanted to have it in person, but then we also decided to have it virtual because of so many other things. And I think all the pandemic is, things are a lot better than it was 2 years ago. But, hopefully next year we'll all have it in person. And so Dr. Latifah Khan and I are the hosts. Stanford only has one condition. We need to have, all of the speakers have to be women. But Dr. Khan he's my colleague. He's done a lot of work for women in data science. In fact, he has supervised many students. He teaches the largest data science course in our university, or of any courses. His courses have sometimes typically 150 students. And so he's a strong supporter, and he and I are co-directing UT Dallas's Data Science Institute. And we are also going to put some presentations together for Stanford on integrating data science and security. And so I would like to welcome Professor Latifah Khan. And then after that, the lady who organized everything, our project coordinator, Ms. Rhonda Wall, she will say a few minutes, and then I will introduce our first speaker. Latifah, can you, so there's Latifah Khan. Say a few words.
Yeah, good morning, everybody. And thanks for the nice introduction, Professor Bhavani Thurasingham. My name is Latifah Khan. I am the professor in computer science at UT Dallas. So I have been involved with this program for a while. So in today's program, we have a very good distinguished speakers lined up. So some of the speakers are from academia, some of them are from industry, and then we will have our own students. So you can see in this program, you will hear some of our speakers' experiences about data science. So first speaker, Dr. Bhavani will introduce her, Dr. Jennifer Holmes. So she will give a motivational speech. Then we will have a keynote speech from Dr. Sanda Harabaggio. Then we have from the industry, we have 2 speakers. And then at the end, we will have the student perspective. So I would like to thank you, Rhonda Walls and Ashrafi, for doing all the work behind the scene. So now I would like to transfer the control to Rhonda Walls.
Okay, so I think I will, Rhonda said that she may have to just step out for a second, so that's okay. What we will do is I'd really like to thank Ms. Rhonda Walls. She's been supporting this event for us, or really managing this event for us since 2018. And every year we have one of our students involved. So we usually have, so we had Dr. Mariam, and then we also had another student the previous time. And then this time we are having Miss Ashrafi Kandakar. She's a joint PhD student in data science, Latifah Khan and myself. So she's giving, so she's the one who did all the organization with Rhonda, did the flyer and so on. So every year we have got an academic perspective, which is our, today we have an academic keynote speaker, but today we are introducing something else as well, which is our first inspirational speaker. So we have an academic perspective, and then we are also very honored to have industry perspective. We have got 2 outstanding industry speakers who are former students of UT Dallas. One is at Amazon, and she will be, I think, the first speaker. Then we have our second speaker, and that is, she's at AT&T. And so we have our 2 industry speakers, and then our student perspective, which is Ashrafi. And then I will give the closing address. My closing address is why a career in data science for a woman. Okay. So having said that, I'm going to, we have 2 minutes. I need about 10 minutes to introduce our first speaker, but then I'll take up all the time. So I would like to introduce our motivational speaker. She is the Dean of our Economics, Policy and Political Sciences. We call it EPS. So she is Professor Jennifer Holmes, and she has been at UT Dallas for a number of years. And Jennifer's PhD in policy, she's one of the top experts in public policy, I would say, in our country, maybe even in the world. And it was at University of Minnesota. And she, we worked jointly with her on a number of our projects in public policy and cybersecurity and policy and data science. So Latifah has some projects with her on data science for political sciences, and then she has the policy perspective. And more importantly, Dr. Holmes and I, she was the main founder, and I'm the co-founder of our very rather unique education in cybersecurity, technology, and policy. So we have a master's program, and that is rather unique in the US. Only a handful of universities have such a degree. So we bring in policy, cybersecurity, technology, behavioral sciences, social sciences, as well as auditing. So multiple schools, or we call it schools, but others call it colleges, are involved. So I don't want to take any, but Dr. Holmes is about 10 minutes. So I will hand it over to Dr. Holmes. I would like to welcome Dr. Holmes. So Jennifer, please, it's all yours now.
Well, thank you so much, Bhavani. Well, thank you for joining us this morning. Women in Data Science is an incredibly powerful and impactful initiative, both for women and for the world. For us in the greater Dallas area, it's especially meaningful since it's organized by Dr. Bhavani Tharasinam and Dr. Latifah Khan. They both are leaders in promoting partnerships between social and computer scientists to create innovative solutions that can be successfully implemented in complex contexts with broad impact. For women, mastery of data science opens a lucrative career path. Few other disciplines have such a high market demand. Women are even more sought after as organizations strive to have a more diverse and inclusive team. For each of us, integrating women and other diverse populations into the data science community has the potential to spark a cascade of inventiveness as a talented, diverse community uses these tools to address wicked problems in government, the nonprofit sector, and in the private sector. First, increasing data literacy is essential to protect our democracy and civic culture. Unfortunately, for too long, the lack of data skills has overlapped with inequities, reinforcing disadvantage. Even worse, many have fallen prey to pernicious conspiracy theories and disinformation, allowing their civic voice to be hijacked by others. We need to work toward a world where all citizens have the power and habit of mind to correctly interpret and apply data in their public, personal, and professional lives. Second, we must promote data-driven decisions in government and in the nonprofit communities. Our participants today can help our leaders have the right information at the right time to make the right decisions about things that are most important to us. Third, data science and AI is transforming modern industry. More and more sectors have access to data that was before too big and complicated to analyze. This jackpot of data, if analyzed correctly, can lead to more efficient processes, better products, new solutions, and smarter strategies. It's an honor to be with you today to hear from UT Dallas students and alumni about how they're taming big data and tackling wicked problems. Thank you, and I look forward to hearing from you.
Thank you very much, Dr. Holmes. I just have a question, if you don't mind. So where do you see specifically the policy issues? I know we do a lot of, so I can see a lot of work on integrating social sciences and data sciences, in particular, applying data sciences for societal problems. Latifah and I are quite involved now in applying data science for social good. And so we are going to introduce, we just got a little bit of funding to do some work in that area, a small amount from NSF to provide some tutorials and give it to minority institutions on social sciences. But I'd like to understand more the policy aspects since we have a few minutes left.
Sure.
So I was wondering whether you can talk a little bit about the policies, how it will help data sciences.
Absolutely. I think there are two great examples from the last few years, right? So the first, of course, is COVID. I mean, you think of that as a very technical challenge, right? We had to get a vaccine, we had to find out effective treatments, but without knowing how to implement these policy solutions or navigate a sea of some people who have distrust in government or don't like vaccines, or you have distributional challenges, all those are aspects of successful policy creation and implementation. So that's, I think, one example we really see, and another one that you and I both know quite well is with cybersecurity. You can have the most amazing infrastructure, but if you can't communicate it to users or your customers, and you can't have your organization function according to its mission, it doesn't matter how secure you are because you can't fulfill your mission. So I think this is just one of many examples where policy and the more technical can really come together to have a well-crafted technical solution that can actually be implemented in a way that supports the mission of whatever organization it is you have.
And one other thing, Dr. Holmes, I think that what we can do is, because of data science, machine learning, right, a privacy, because you've got the ability now to put all this data together and infer something that is highly private, or maybe the fairness aspects, right, with data science. And so do you see, I mean, we can come up with appropriate policies in terms of, with respect to data science, limited use, how do you collect data collection policies, and so on. Will the policy experts be able to support the data scientists that way?
I sure hope so. I think that a great example is, people are very worried about the government collecting information, but there's not much concern about companies collecting information. I mean, Facebook, Google have more information on most of us than any government. So we definitely need to work together to have, yes, harness these tools, but also protect individuals' privacy and their agency. That's just incredibly important. You know, one thing we see around the world and in dictatorships, especially, that authoritarianism, if they can get a hold of these data, their tracking capability is very, very significant. And so we need to protect people both here, but also abroad from you know, pernicious uses of that technology and that information.
Thank you very much. Before you go, I was wondering whether if anyone knows how to take a photograph, because we want to take some photographs off and on. Dr. Khan, can you take a photograph?
Yeah, sure.
Okay, of just of all of us here. So I'll ask you to take some photographs off and on, okay?
Give me 1 minute.
Yeah, you may want to move to the right, Latifah, because we can't see your face, I think.
Sure.
Right or left? No, you're going to the other side now. No, to your left, sorry. You want to move to your left.
Just 1 minute.
Where's he gone? So, oh, okay.
There we go.
It's much better now. Move to your left a little bit. Okay, oh, perfect. Okay, now take a photograph of everyone. And oh, thanks, Ashrafi, for joining. So as you can see, no, you can someone use the Zoom to take the, not Zoom, the
I'll do a screenshot.
Screenshot. That's what I was asking. Yeah. Jennifer, yeah, if you can take a screenshot.
All right, one, here, Laura, look up and smile. 1, 2, 3. Got it.
Thank you. Thank you. How do you take a screenshot, by the way?
On Apple, what is it? Shift Control 4. Is that it? No,
Okay.
Sorry. Function Control 4, something like that. And
Okay. So Ashrafi, I think I want you to also, please, if you're there, right? Please learn how to do the screenshots. Thank you. Because I'm going to assign you to take the screenshots, not the iPhones.
Yeah, Professor, sure.
I took a screenshot also.
Oh, you did. Thank you. Sorry, I said the photograph. It was my fault, okay, because I said photograph. Thank you so much, Dr. Holmes. We are just
Thank
about
you.
time for me to introduce the other speaker. I know you are a dean. You have to manage so many things, and especially these days with COVID, I know deans are just, there's too much work for them. So I'd like to thank you so much for giving this inspirational address and giving a different perspective, actually a social sciences perspective, which was really very important for us. Thank you so much. And then let's give her a hand.
Thank you.
I think we need to give a hand with some clap from here, right? Oh yeah, clapping. Let's see if they can clap. Oh, okay, applause. Okay, so we have clap. Okay, so now we are going on to our keynote speaker. Thank you, Jennifer. Right. So now we go to our keynote speaker, and I would like to introduce, we have very distinguished keynote speaker, Professor Sanda Harabaju. And Sanda has been, our colleague for many years, and she's a top expert in natural language processing and artificial intelligence. She is the research initiation chair professor at UT Dallas in our computer science department, and she's also the director of the founding director of the Human Language Institute. And so she's done a lot of work. Her PhD is from the University of Southern California, and she's done a lot of work on natural language processing and artificial intelligence and data science, all those areas sort of integrated with also a number of applications, in particular in healthcare and some other applications. And so now we are just about time for her presentation. So just to let you all know, every year for our keynote speaker, we have a female professor from UT Dallas. So we have done that since 2018. So every year we have our professor. So this year it's Dr. Harabaju. And again, we'd like to thank Dr. Harabaju for agreeing to give this keynote address. So I will hand it over to you. Thank you.
Thank you, Bhavani. Thank you very much for inviting me to give this keynote, and thank you for the audience and the very interesting talkers. I think it is a wonderful opportunities for women, and not only women, to participate in this forum on data science. So I have prepared a talk with some slides. So I'm going to share my screen with you.
Yeah.
It's working. Okay.
Oh, good.
All right.
Yeah, I always get worried about sharing screen because with Zoom, we got to hand over all the control, right?
Exactly. You never know what you're sharing, but hopefully not big secrets. Okay, so this morning I would like to talk to you about a perspective on data science between competencies and automatic data science models. And that is particularly interesting from the academic point of view. So let us start with the definition. We academics would like to define the concepts we are presented. What is in fact data science? It really covers a full spectrum of insights from data, from the initial data gathering and its interpretation, to its processing and engineering of the data, to exploration and modeling of the data, and eventually producing novel insights and decision support systems. And you see, I have underlined some of these aspects, like gathering data is complex, but the interpretation of data is the more difficult problem. Then the processing involves a lot of different methods, because it can be seen as overlapping in scope with other data analytic methodological disciplines like statistics, machine learning, databases, or visualization. But also this processing must lead to some modeling, and that's where part of my talk is concerned with the need of automatic modeling of data science, and eventually these novel insights which are very specific to the application, and that may lead to some decision support systems, like for instance in healthcare, a lot of the treatments are guided by such systems. I was wanting to also highlight the fact that this symposium is also meeting an interesting aspect, because this month the communications of the ACM is dedicating its main research article to this topic of automatic data science. And I highly advise everyone to consult this specific article, and also some other companion articles that have appeared in March 2022 of the main journal of the ACM. Now, one of those articles inside of this journal talks about analyzing data, which is another way of expressing data analytics, and highlights the fact that analyzing data is essential to success in education, employment, and other areas of activities in this knowledge society. I really like the way they coined, we keep on hearing about digital society, but it's actually a knowledge society. And they were asking the specific question, what specific skills are required to succeed in data analytic assignments? And that is particularly important for academia to know what kind of skills we need to empower our students with. And they concluded that there are 65 competencies that were derived from a Delphi study, and I'll talk about it in a minute. Which identify these competencies along cognitive, interpersonal, and intrapersonal aspects. So what are these competencies? Let's define them again. They are the individual's personal characteristics that may influence how that person approaches data analytics tasks and acquires data-relevant knowledge and skills. And in the quest of finding these competencies, they try to use a framework that compiles some expert consensus around these required competencies for data analytics. And that is very important for higher education institutions, because knowing which competencies our students must have could help us develop curriculums and enhance the student development and help them be knowledgeable about research and being fine researchers in their work. So this is a bird's eye view of these competencies that came from this Delta technique. So you see there's a lot of them, and there's these bubbles around a variety of aspects like reasoning and argumentation, critical thinking, continuous learning. So you have to continue to acquire more knowledge. And so forth. And as you can see, not only that they are across a large spectrum, but all of them seem to be having a high influence. So let us see how this was achieved. What is this Delta study? So they started by thinking, well, what are these competencies? And they started gathering a set of experts, looking at their LinkedIn profiles, also looking at publications and a whole network of experts. And from the beginning, they thought that there are three different types of skills that people working in data science should have: cognitive skills, interpersonal skills, and intrapersonal skills. And that is very important because we generally focus on cognitive skills, but also this interpersonal, the ability to think and to learn, are also equally important. And the intrapersonal, the teamwork, and the ability to create a good environment for teamwork. So they started with the first survey, designing it, and then they analyzed, the experts analyzed, and then they spent another 6 weeks where the 65 experts integrated more of the background. Then 43 experts spent another 3 weeks in a second iteration, and at the end, the third iteration involved 35 experts for 3 weeks to generate this competency and to skills, and to see how much, what weight they gave them. And here you have the most important skills that are required. So you may notice that they are across the cognitive and also the interpersonal and also the intrapersonal aspects. I'm trying to set my pointer, but my computer does not allow me. So looking at the cognitive aspects, we look at very highly rated the ability to perform analysis, problem solving, reasoning and argumentation, and critical thinking. In terms of intrapersonal, which involves the person itself, it's continuous learning, intellectual interest, and responsibility. And in terms of interpersonal, with a little bit of a lower percentage of consensus, it's trust, collaboration, sharing information, communication, and commitment to trustworthiness. So when one looks at the absolute consensus, analysis clearly comes as the top skill, followed immediately by continuous learning and problem solving. This is something that we have been focusing on in academia for a long time, to teach this kind of skills. But less we have, we also need to spend more time focusing on critical thinking and intellectual interest and responsibility, which are part of the intrapersonal skills that are required, and urging students to develop this ability to be interested in continuing to learn. In our academic efforts, we have to develop also this interpersonal abilities to collaborate and to trust. But as we develop all these skills, we also have to be aware of the observation that there's a shortage of trained data scientists with the appropriate background and expertise. Even if our classrooms are filled with eager students, very intelligent and very willing to acquire these skills, there are not enough of them. So modern data science requires broad knowledge and experience across a multitude of topics. And together with this increasing demand coming from industry, there is a shortage of trained data scientists with appropriate background and experience, and significant market competition exists for this limited expertise. So what can be done? the solution is to try to create an automation of data science, which aims to facilitate this transition of the work of the scientists, not to replace them, to help them. So there's been an increasing interest in automating parts, but not all of this data science process. So how can we perform automating data science? Broadly speaking, automation in the context of data science is very challenging because the process is complex and it depends on the form it takes. It ranges in complexities depending on whether it involves a single task or the entire iterative process, or whether partial or complete automation is the goal. And the article I mentioned in the communications of the ACM is trying to take a very nice first view of that. What would be the first form of automation? Namely mechanization. That occurs when a task is well specified and there's no need for human involvement. Examples of such mechanizations are, for instance, the clustering algorithm, which are unsupervised ways of wrangling the data. This can be done by functions or low-level language functions, or even libraries that encode algorithmic packages that are existing. A second form of automation refers to composition, which deals with strategic sequencing of tasks or integration of different parts of the task. With other words, knowing that a certain task must necessarily precede another task and so forth. And there's some support for code or workflow reuse that is available right now. And here I'm giving 2 examples, like interactive workflow-oriented studies, like RapidMinder or IBM Modeler, and also high-level programming languages that have been developed, especially for commonly used environments like R and Python, and also for deep learning like TensorFlow and PyTorch. And I have to say that in our classes, we engage students in their projects and homeworks to become fluent in this environment. Now, the third form of automation deals with assistance, which derives from the production of elements such as visualization, pattern explanations, that are really targeted and supporting some human efficiency. That it consists of monitoring what humans are doing and during the data science process and what could be automated and assisting them. And a clear example of that is active learning. So a lot of the interesting data and analytics can be performed nowadays in the realm of social network analysis or information that is being spread on social network platforms or social media, as we call them. And it's interesting because computational social scientists, so as you see now, we're not only computational scientists, but we also have to involve the social aspect of it, may wish to explore a social network to gain understanding of the social interactions that it describes. And I'm going to give you in a moment an example of such explorations that I have been doing with some of my students. An example is that an analyst may decide to look into some community patterns or to formalize subsets of the nodes and the edges connecting them to really find out what characterizes those patterns. And that's in the broad context of data exploration. It turns out that there are 5 subtasks that can be potentially automated, and these are forming of the patterns, which include options that look at the high-level topology of the network, the degree distribution, the clustering coefficient, or the existence of dense subwords or communities. And that's a very interesting aspect of the formation of patterns, trying to recognize the communities in the social networks. Then another subtask is measuring the pattern interestingness. So you might derive some patterns, but not all of them are equally interesting. So interestingness can be quantified as the number of edges or the average node degree with the community, the local modularity or subjective measures that depend on the analyst's prior knowledge or measures developed from scratch. But also, I think that to this must be added the kind of communication, what kind of things they communicate about. The third subtask is some algorithmic strategy, like optimizing this measure that you want to consider, that will require some graph theory, some heuristic search, or some bespoke approaches. So now we know that a lot of work in social network analysis and also in natural language processing involves around deep graph models that can really be very successful. The fourth subtask deals with pattern presentation, because the most interesting communities can be presented to the analyst as a list of nodes, and they can be marked as suitable permuted adjacency matrices or other visualizations of the network that can bring a lot of insight. And the fifth subtask has to do with the interactions, because the analysts will want to iterate on some subtasks. For instance, the analysts want to have some input to retrieve more communities, to explore over other patterns, or even intervene on the algorithm to inform it and lead to better accuracy. So in the remaining time, I would like to present to you a case study, and that bridges a little bit with what Dr. Holmes said about misinformation that is present on social media platforms. And I'm going to talk to you about a case study, the data discovery of on social media platforms. And as we are in the middle of a pandemic, some say that we are entering an endemic. However, misinformation is out there, and it will continue to be spread, and we have to have data analytics methods to identify it and then eventually intervene on it. So of special interest to us was the discovery of misinformation about the COVID-19 vaccines. Misinformation is thought to be a big driver for vaccine hesitancy, and therefore it is important to know what kind of misinformation is out there. So I'm giving you here a very small example. There's tweet one here that says, there's no vaccine for COVID viruses. This vaccine changes the DNA. That is not a vaccine. That is a manipulation of humanity. And that actually is evoking a misinformation target that the RNA alters a person's DNA when taking the COVID-19 vaccine. As you see, they are not the same words used in the target and in the tweet, because this has to do with the generative power of language. We can express the same idea in millions of forms. A second tweet that evokes the same misinformation target says, this vaccine contains MRC5, aborted fetal cells. This COVID vaccine can change your DNA, end of story. This tweet evokes not only the misinformation target A, that you know, you are going to have your DNA changed if you are vaccinated, but also a second misinformation target, that the COVID-19 vaccine contains tissues from aborted fetuses. So it is interesting that these misinformation targets have their own social value, because here they also refer to a lot of moral values and moral foundations that people can be influenced by when making decisions. So our first goal here was, well, how can we create a data analytics method that would first recognize what are all the tweets that evoke a certain misinformation target, and you see one tweet can evoke more than one misinformation target. And where can we find these misinformation targets? So we can all hear on the news, in the media, that there's a lot of misinformation, but there was very little effort in trying to identify what specific misinformation is being discussed on the social media discourse. And here I'm giving you examples from Twitter, but the same kind of phenomena are found on Facebook, on Instagram, and many other platforms. So what are these COVID-19 misinformation targets, and where can you find them? So this was something that we have done earlier last year. We tried to find where there are sites that gather this kind of targets. And we know that misinformation has widely propagated across the world, and in English it created a decreased vaccination intent in the UK and the USA. And medical, public health, news organizations, they all scrambled to collect and rebut this misinformation surrounding the COVID-19 vaccine in response to its spread. But it was not done in a very intelligent way, because they were not identifying clearly the targets. They were just, you know, a million voices discussed about a million vague issues. Some organizations, such as the Mayo Clinic, the University of Missouri Healthcare, the University of California at Davis Health, the University of Alabama at Birmingham, also Public Health as an organization, and even Snopes and the BBC, they all have actively collecting misinformation about the COVID-19. And they try to debunk them on their public website. And that turned out to be gold for us, because we could go there and really start identifying these targets. Wikipedia has also an entire webpage dedicated to COVID-19 misinformation, but this one collects misinformation and misconception claims, including those referring to the vaccines, but there are very few of them. And even the idea what is misinformation, how can we define it, is very discussed. It can be a reference to a misconception, but also false reasoning, and also ideas that have been debunked by news organizations. So remember, some of the ways of doing, creating models and automating data science is through assistance. And here I'm providing a slide with 17 different misinformation targets that we have collected from these the various sites, and the tweets that we have discovered that evoke them, and how we have created graphs of tweets that all evoke the same misinformation target. And as you see, these little graphs look a little bit like some coronaviruses themselves. Some of them are extremely dense, like the one referring to 4, which tells that the misinformation target number 4 is that COVID-19 vaccine causes Bell's palsy, which is clearly a misinformation. Another very dense one is misinformation target 9, that there are severe side effects of the COVID-19 vaccines worse than having the virus. This comes from a paper that we have published in December, which is openly available now. You know that the National Library of Medicine is opening all the publications that refer to COVID-19. So what is assistance? Assistance means the ability to formalize this problem, as we have done, into some graphs, and the ability to create predictions of every tweet as belonging to a certain misinformation graph. And that can be automated because we were able to download about 10 million tweets, and were able to identify which one of them evoked this 17 misinformation targets. Now, part of assistance is also the fact that how do you know when you have all the targets? And that was part of another paper that we're publishing now, learning to discover these targets, not only gather them from health organizations or BBC. Now, people also have to consider that the composition aspect of automating the creation of these models about misinformation, because not all the tweets that are identified turn out to be relevant. So you see some of the tweets about misinformation that vaccination means microchipped tagging turn out to be much more relevant than the unrelevant ones. But you have tweets that refer to vaccines containing substances that are allergic to those that have allergy, that are mostly irrelevant. So then you have a model that would be built on mostly irrelevant information, and that would clearly impact its accuracy. So that is the role of composition. Then the mechanization has to do with how do you really wrangle the data. You know, and wrangling the data nowadays is mostly through some neural architectures. So this was a baseline neural architecture that we cast as a binary classification using BERT, which is a widely used contextual transformer-based bidirectional architecture. So how did we get it? Is it all just automating these models? What is important is at the end, what are the results? And here I'm giving you a representation of the results we have obtained. So BM25 is the state-of-the-art information retrieval relevance model, and that would have obtained an F-score of only 51%. Then these methods of using either BERT or LSTMs as binary classifiers get an F-score of 54%, so very much improving the F1 score, or 76, that shows that BERT, having the ability to really get the contextual language representations, really obtains much better results. But our finding, as we created the state-of-the-art model, was that, in fact, we should use knowledge embeddings. And knowledge embedding models have different link prediction formulations. And we have learned that basically using trans-MS was the one that obtained the much better results overall. So with this, I'm ending my talk. I gave you just a little drop of where data science can be applied and what are the definitions and what is the academic perspective of this. And I thank you for your attention.
Thank you so much, Dr. Harabaju. This has been a wonderful presentation, very appropriate for our conference, so that we can, this will sort of help us, especially in the healthcare area. So this has been just great for us. And so I have a question really. So how do you see sort of the future? What do you see, especially in particular, we are all thinking about COVID-19, right? So how do you think data science can help us in various aspects of COVID-19, detecting, maybe preventing, developing, just very high level, developing sort of treatments and so on, vaccines? Can you just give a sort of some sort of insights into what you think, how data science could help us?
Well, I think that tackling the COVID pandemic has two aspects. It is clearly the treatment aspect, the incredible effort that was done by scientists, and the fact that the vaccine and several vaccines were developed so quickly, and billions of people got vaccinated, and therefore they were saved by these horrible infections. Also, on the other hand, the fact that now we have these antiviral drugs that if somebody tests positive, they can take them immediately, and especially the fragile or the immunocompromised people. So that is the clinical aspect of it and the biomedical aspect of it. But then we have the other aspect, which is equally important, which has to do with public health. So if people, if these tools are available, if these treatments are available, if this prevention is available, but people refuse to take them or ignore them, that leads to a lot of loss of life and a lot of complications. Therefore, I think that this pandemic has really shone a light on the fact that efforts in public health were disregarded for a long time. There are very few experts in public health. So what data science can do is the following thing. First of all, we have to work together with public health experts. So I've been working for the past 2.5 years with the professor of public health in California. And what we're doing academically, we cast this kind of problem. So one of our goals, we just sent a proposal to NIH, was how can we identify the various profiles of hesitancy? And why is that important? Because once that's a public health kind of aspect. If you identify why people are hesitant, then you can intervene on them such that you can change their mind, such that you can increase their intent for vaccination. This happens not only for the COVID vaccine. It is amazing that there are several other vaccines that have very high hesitancy. One of them is preventing cancer, the HPV vaccine, which is very problematic because a lot of parents refuse to vaccinate their children. And therefore, instead of protecting them from ever having these horrible cancers that are determined by HPV, they lead them to have a life that might end up with a lot of suffering, right? So as data scientists, first of all, exposing our methods to public health students is very important. And secondly, working together with them such that once that we identify this these profiles of hesitancies, there are methods in public health of interventions and making a lot of people change their minds. And I think that that is equally important. It's not only treatment, it's also prevention and accepting the prevention that where we have to work with them.
Thank you so much. And very, very interesting, very enlightening presentation. So we'd like to, Dr. Khan, ready for a photograph for Ashrafi? When I say photograph, a snapshot. Dr. Khan? Ashrafi, can you take a photograph, a snapshot?
Yes, Professor, I'm taking it.
Yeah, okay, great.
I can do it also.
Okay. Thank you so much. Yeah, we are clapping. Thanks a lot, because we want to move on. So is it ready? Have you all taken it, Ashrafi?
Professor, can you one more time?
Dr. Khan, have you taken it?
Yes.
Yeah,
yes.
I did, yeah.
Oh, okay. Ashrafi, please learn for next time, okay? Thank you so much, Professor Sanda. So Ashrafi, have you learned how to take it now?
Yes, Professor, I took it, but actually I wanted you to pose again for that. So.
Okay, that's fine. We're all fine. Thank you so much. And so I'm still clapping here. What should I do? Okay. So now I will hand it over to Professor Latifah Khan. I'd just like to say a few words about him. Earlier I said, you know, we are very thankful to him for co-directing, because we also need men in the presence. Unfortunately, he cannot talk because not being a woman. That's a Stanford University's WiDS rules. We are all part of the global data science effort. So one thing I wanted to mention, just Dr. Khan, if you can please move to the left a little bit, because we can't see you. So is it Ms. Pallabi or is it Dr. Lippi? Who is going to give the talk next? Dr. Khan?
According to the schedule, the Parveen, yeah, Dr. Pallavi Parveen is supposed to give the lecture.
Oh, sorry. So I'm going sorry, Dr. Lippi. I mean, it's going to be Dr. Parveen. Okay. So I will introduce Dr. Parveen. Again, thank you very much, Dr. Parveen, for agreeing to give. I know we are a little bit late, so, but that's fine. I can cut short my presentation. So let's not worry about that. Because, you know, I gave myself like 20, 30 minutes. I'll just talk for about 10 minutes. So I'm really honored to introduce Dr. Pallabi Parveen. Dr. Pallabi Parveen is very special because she was my PhD student and master's student. So she was my master's student and she did her work on face recognition, and then a PhD student where her work was on big data analytics and cybersecurity, integrating the two, as well as some of the applications of big data. And she graduated, gosh, almost what, 8.5 years ago. And she's held some very interesting positions at, first she was at, I believe, Cisco. And now she's also, while she was at after she finished her master's, she worked for Texas Instruments. And now she's working, I think she's a principal researcher and developer at, she also worked for EMC, and now she's at AT&T, and she's a principal big data software engineer. Thank you very much, Dr. Pallabi Parveen, for giving this featured presentation. So it's all yours, and you have 20 minutes, right? So you have around, we are running around four minutes late, so, but we have to strictly stop just before 9:45. Okay, thank you.
Yes.
Please continue.
Thank you, Dr. Professor Bhavani Turshingam. She was actually my advisor, she already mentioned. So I'm Pallabi Parveen. I worked as a principal big data software engineer at AT&T. So today, actually, I will be discussing about data science or cybersecurity and big data. So now the background, how did I get here? I was actually born in Bangladesh, And I had very keen interest to be becoming an engineer and also at the same time as a scientist. That's why when I decided to be studying computer science, and I did my bachelor from Bangladesh University of Engineering and Technology from Bangladesh. Now, next, I wanted to pursue my higher study, and I decided to come to USA, and I finished my MS and PhD under Professor Bhavani Turishingam. So she was my advisor, and she was very helpful during the process of my master's and PhD, and she guided me a lot on this journey. So I finished on this. I did after finishing my PhD. So next, in the meantime between my PhD and masters, I did couple of internship, and then after finishing my PhD, I worked in a Texas Instrument where I worked on a Android phone, and I developed software for camera and sensor between 2007 to 2008. I worked also in Dell EMC, where I work mostly in cloud computing on Converse infrastructure. And we have worked with big data. We collected a lot of data, and we saved those in Cassandra and Elasticsearch, which is ES. We use different kind of analytical tools also in Dell EMC. Finally, actually, I landed to AT&T as a principal software engineer from 2007 to current as of now. And there, I'm mostly working in a chief data office, which is like collaboration of big data, automation, and data supply chain. So we are working on finding anomalies like threats and all those kind of things. And we have huge amount of network, as we know that AT&T has a lot of cell data and all those different kind of network traffic data. And we are continuously trying to find any anomalies within this network data, or on this any kind of threat is there. And different kind of threat recently that we are looking at, like if you whether you have heard about the SIM swap, because recently there on the cell phone it's happening. There are a lot of cases we are seeing that some of the customers see cell phone is being swapped by a threat person, and then we have, and there is no clue, like the person whose cell phone is swapped, he doesn't know actually, and in the meantime it's still all the information on that cell phone. So it's better to identify this kind of SIM swap within our organization as before it damages the particular person, like financial, before it caused mass financial damage to that person. So those kind of anomaly and threat detection, we have to continuously have to do that. And also, like for that, we have to use some data science technique, and we have to continuously analyze the data and also apply some different kind of machine learning methods to find out that those kind of anomaly when this kind of behavior is occurring within our network traffic. So these are some example of like what we are doing within AT&T. Also, there are a lot of data scientists and analysts within our team. We are collaborating with each other. We are developing ideas for cybersecurity using big data. And recently also we are using cloud computing because we are moving towards cloud infrastructure, which is actually mostly we use both AWS and Azure for cloud infrastructure. And we are also using the Databricks for our any data science analytics, which is built with Spark underneath. Most of the time we are using Scala and Python and different techniques on the Databricks. And we are also using different deep learning and different statistical models also for our data science purpose. So these what we do in AT&T. Now I will just go briefly about my profession, education and certification, all those things. Profession, I already mentioned that what I do. And about the education, I I have already covered that, so I'll go with my certification. Every year, actually, in AT&T, and you have to grow yourself. So every year they want us to take some certification. So recently, I also took a certification on postgraduate program in data science and business analytics through this is a joint project from UT Austin, so which I have completed recently. And then we have to also, because we are using Databricks heavily for Spark, which is very good for big data, any kind of, when you have a big data and a lot of huge amount of data you need to handle, and Spark is like a kind of distributed environment. It's a cloud computing environment where you can use the Spark, and you can make the process faster, and you can save the time also. So for that, we use Databricks a lot underneath, which is Spark, and for that we have to take a Databricks certified associate developer for Apache Spark 3.0. There are some other certification I have also taken on Databricks, but this is the most important if anybody is interested on. Then for the cloud computing, we have to take some fundamentals, Microsoft Azure fundamentals, and all those. Sorry, something glitch happened to my screen. Just 1 minute. Let me fix that one. Yeah. So these are the certification. If you are interested, if you all can take, it's online, and you can also you can take it by yourself. And the next is publication. I have also done some publication in AT&T also. So as a whole, I have 11 papers in IEEE conference paper, and I have 2 journals, and these are the publications. I'm also looking forward to do more publication within AT&T and moving forward in this year. Some of the activities that I am heavily involved in, which is Global Women in Data Science, organized by like this data science conference, and also I participated in second IEEE Women in Services competing workshop, and different other activities I've also involved in several times. I cannot here. This just I'm giving you some brief idea of what I do. Next. So here is some certification and training links if you are interested, like from where I did my postgraduate data science and business analytics from UT Austin. These are the links here. And then that is where I took the Azure fundamentals and also the Databricks. If anybody is interested, I can share these links. For the training materials, if anyone is interested, they can go to Udemy, and there are some Coursera where you can take some training materials, and for online tech courses and nano degree program, which is very we do some nano degree program, like it's very small amount of, like it's a 6 months course, but you understand the topics very well, which is done through the Udacity. You can take those also nano degree programs to enrich yourself with more knowledge and information. So next, I'll be moving on. Now, here is a slide which will show that why we need a big data and what is the importance of big data and how do we handle that. So here I will run a YouTube video which is taken from online, and I will pause for a couple of minutes from here. So we get an idea about what is big data and how we can handle it. I mentioned that we heavily using Spark for big data, like any kind of computing. We use Spark and machine learning both together, and there is a very good platform for which we can use, which is Databricks underneath, which is Spark as well. So this is for big data. Next, I will go with the data science. So usually when we think about data science, we usually we believe that, okay, this is maybe a machine learning, everything related to data science is the machine learning, and that is what is data science about. But actually data science is actually is the intersection between three different concepts, which is like under computer science, and then it's something kind of math and statistics, and also we need some subject matter expertise. So for when we mention about when data science is a like combination of three infrastructures, which is statistics, because when we look at the data, we need to understand the data very well, and for that we need two persons. One is subject matter expertise. Suppose we are looking at medical data, so we need some medical profession from there to look at that data and understand the concept of the data before we analyze or do some machine learning, apply some machine learning technique on that. So it's a specialized person on that data is very important for a data scientist, having a specialized person on that data. Now the next part is the statistics. So when we within the data, there are a lot of things like we need to know that whether that data is a very clean data, is there any missing data, is the data interpreted correctly, and some sort of a statistic analysis we need to do and clean up before we do this. We go for machine learning approach on that data. And finally came the computer science, which is underneath where we can do the machine learning and to do some like analysis, and then through that model we can generate some results, like some output, like whether it is we have to find something, some anomaly in the data, whether this is an anomalous data or not. So that is the final part where machine learning is very important, and which is under computer science department. So now for the data science, as I mentioned, this is a large amounts of structures and unstructured data. We have to identify the patterns between all this structured and unstructured data. For that, usually we use Python, R, statistical mathematical skills, and also we need to do some visualization of the data to understand it. We also use Databricks and machine learning. Now, there was according to SVP of Gartner Research, they mentioned that information is the oil of the 21st century and analytics is the combustion engine. So we have oil there, but in order to burn it, we need that analytics, and which is the data science here. And there's another saying that wisdom comes from good data. A great analysis can go wrong when data is missing, duplicated, misunderstood, or just plain wrong. I think in my previous presentation, already Sandra and other presentation has mentioned how the data can look and what is the meaning of missing duplicated data, or like if there is some missing data, is there misinformation there? How do we clean up those data and how to use those data into our machine learning tools? So this is very important before we think about like, okay, I'm going to apply some machine learning techniques. But before that, looking at the data, cleaning the data, and find the particular features out of the data is very important as a data scientist. Like you have to be very careful with that one. Otherwise, no matter whatever machine learning tools or techniques you use, your result will not give you what you want. So next, concept for data science. So as I mentioned, like you have to do first data cleanup, which is like there will be some missing data and wrong input. How do we clean up? I think we already know that usually there is a tendency when there is a missing data, we just drop that data. But usually that is not very wanted way to do. instead of we can replace that data with some median values. So those kind of things we have to keep in mind when you are dealing with some missing data or wrong input data. And there we have some categorical versus numerical data. How do we handle those things? That is also an important fact you have to think about when you are using those data. So before you go for machine learning, you have to do some visual analysis, which is like you can do univariate analysis, you can do bivariate analysis, you can do multivariate analysis, and all kind of analysis you do before you go for a machine learning technique. And then there's the third part is the very important, like most of the time we don't, because the data is a huge amount, the original population of data is a very vast and huge amount of data. So we don't use the whole population data, though we have a big data concept there. We can use Spark to make our computation time faster with big data, but we cannot take the whole population. We have to take the sample of that population, and that sample we have to be very careful whether that sample represents the population or not. And with that, what we can do, we can compare there are some kind of statistical tests that you use, which is g-test, t-test, chi-square test. I'm not going to it all. I'm just giving the point here. Like we can use those kind of tests to verify that whether this sample represent that population. Otherwise, if we take a sample and then do some machine learning analysis on that, and that sample may not represent your population. So you have to be very careful with those kind of things. And finally, you have to choose appropriate model, which kind of model that you want to apply on that. There are many different models that nowadays, like XGBoost and isolation forest and different kind of model, deep learning, different kind of approaches there. You have to know that which model we have to apply for your data and what is appropriate for this data and what kind of model is appropriate for that. So those kind of things you have to keep in mind when you choose some machine learning model. And finally, then you have to do the hyperparameter tuning to find out the right parameter for running your model. And for that, you can use different scoring method also, which is precision recall and F1 score. And finally, you have to know the right cutoff or threshold where how we can put the threshold where to find your, like, this is a positive case or this is a negative case. So those are kind of things you need to understand when you think that you are working as a data science and you want to bring a better result for your analytics. So now I will skip this slide because I think I have.
We have just like 1 or 2 minutes left.
Yeah, so I'll skip these slides. So you have to do all this kind of bar chart and all those analysis of your data. How do you do that? Then you have to detect the outliers also here. Like you know that there is, you can do the box plot where Q1 is the 25 percentiles and Q3 is the 75 percentiles, and outlier would be outside of this region is the outlier, and outside of the Q3 plus 1.5 QR is the outlier. You can adjust these values also as well according to your need. And for the hypothesis testing that I mentioned with population and sample, you can do different kind of hypothesis testing. Here is a chart. If anybody is interested, I can share that one with you, but I will skip this one as well. So now what we do at Women in AT&T. So we know that math and science are male dominated, but if you look at the statistics for women at AT&T, most of the 69,000 women is more than woman is working, like more than 1/3 woman is employee in our AT&T is women. And then we see that 20% of the total women working at AT&T as in STEM roles, and 35% of them is our managers. So we can see in data science, a lot of women is working in data science than in IT sector in AT&T. It's a big fraction of the women are working in AT&T here. So now Now here in AT&T, what we do, we develop new methods for analyzing massive data sets. We are developing novel methodologies. We are doing some statistical computing. We are doing event prediction. We are also doing the fraud detection, visualization, text mining, data stream management. We do the data quality and anomaly detection, and we also do the
we are really, you know,
privacy preserving measures such as data anonymization.
Yeah.
So scope with with AT&T that you can do publish papers. We can you can do some some counter training and nano degrees within AT&T. And this is my contact. You can contact if you want further information about different approaches that I have mentioned. Then you can contact me. This is my email address. So thank you so much. And if you have any question.
Thank you so much, Dr. Parveen. Excellent presentation. I know we are running out of time, but I have a question. But before that, we need to take a photograph, but we'll do that after you stop sharing. I have a question. One is very briefly, our students might, you know, because we are going to put it on the website and inform everyone. So your certifications, you said, right?
Yes.
How has it, can you sort of say a little bit how they help a professional person, these certifications?
Because through the certificate, you get the training, right? So you get proper training, and your certificate also validate that you are trained on that particular topics properly. You have a very good understanding on that topics through that certification. So when you have multiple certification, the company will see that, okay, this person has certification in Spark. So this person knows the Spark very well, and then we can hire them in the big data sectors. So
Right.
those kind of things is very important. And if you, that's why I would recommend the students to take more certification when they're applying to some company, because they're very looking at those certification very they are looking at the degree also, their qualification, what are the courses they are taking. Apart from there, the certification also helps them to get their jobs.
Yeah. Thank you so much. Now, can you stop sharing so we can take a photograph?
Yes.
And then we'll have Miss Latifah. If you can, okay, maybe we can do it with,
Okay.
better stop sharing so we can take a photograph of everyone. Okay, thank you. And so, Ashrafi, could you please take a photograph?
Yes, Professor.
Ashrafi and Dr. Khan. Thank you. It was a wonderful, I wish we had more time. I'm really proud of you, Dr. Parveen. You are doing, where's Dr. Parveen? We don't see her.
My video go, okay. I think it just.
Okay, let's take, oh dear.
Yeah, something went wrong, like video.
Okay, so Ashraf, if you can take a photograph now.
Taken one, Professor.
Okay, thank you very much. Thank you. Sorry, Dr. Parveen, we don't see you. Okay, thank you very much. I think this is going very well. So I'm really proud, Dr. Parveen. You have done so much. Thank you. So
Thank
we'll
you, Professor.
Thank you. We are around 5 minutes. We are kind of behind. So that's okay, because I can give mine just for 10 minutes. So my presentation. So don't worry. So we'll have full 20 minutes for everyone, at least. So what happened to the screen? Why is it, Dr. Khan? Hello? Oh, now
yeah, I'm looking, yeah.
Okay, now everything is fine. So maybe Ashraf, if you can take a photograph now, a snapshot.
Okay, Professor.
Yeah, we did. I think you can introduce.
Okay, so Dr. Khan, yeah, I'd like to introduce Dr. Khan. As I've already introduced, I just wanted to say, so he's really the Mr. Data Science at UT Dallas. He's got this hugely popular class. He's also a fellow of IEEE. He was recently elected a fellow. So he's really doing extremely well. And so I will, and again, he works with me on Women in Data Science. So Dr. Khan, introduce our distinguished guests, our former student. We are very, very pleased, from Amazon. Thank you, Lipi, for, I mean, you logged in at 8:30. That was what? It is 6:30, I forgot, 6:30 in the morning. It's too early for me, 6:30. So anyway, Dr. Parveen, please introduce Dr. Lipi, and then we'll have Dr. Lipi for 20 minutes. Okay.
Sure. Lipi graduated from our UT Dallas. She did her master's from here, and now actually she took my class, and and then now she has been working with Amazon for a while, and she has been promoted to an important position, I think. So Lipi will elaborate that more details. So
Yeah.
she joined from Seattle area, so the time difference is 2 hours. We are very grateful for joining from there at this early time.
Actually, just a minor correction. I'm in Texas, so don't worry about the time zone. I'm
Okay.
just no worries at all.
So I don't feel so badly then.
No,
Yeah. So,
good.
so we are very honored, Lipi. So why don't you start your presentation? Thank you.
Absolutely, yeah. So because the data science and overall overview of data science is explained very well in the previous presentations, I'm going to focus more on my role here at AWS, and then focus on what we do here in my team, and then share some of my learnings from my journey. Okay.
So Lipi, you're a senior manager, right?
Yes.
Thank you so much.
Yeah, no worries. Yeah. So as you know, my name is Lipi Patel. I am a technical operations manager at Amazon Web Services, AWS, where I am currently leading a team of 13 very passionate and data-driven big data experts, specifically focused on artificial intelligence and machine learning, right? My team works on helping global AWS customers who are using AWS services on AI/ML domain to help solve their complex problems and develop their enterprise solutions. So as Dr. Khan was saying, I'm also a UT Dallas alumni. I graduated with my master's in software engineering in December 2016. I have my bachelor's in information technology from India before this, right? And after graduating from university, or when I was studying in university for my master's degree, I had a 2-semester long software developer internship at MoneyGram. So, and then after graduation, I was offered a full-time role there. So I worked there for about a year, and my role as a software developer there was focused mainly on developing external enterprise solutions using C# and .NET. And that role allowed me to learn a lot of new challenges, but I developed this interest in cloud computing and big data during my time at UT Dallas, specifically from Dr. Khan's course that I took for big data, right? And so I was curious to explore the industry side of it and eager to know about how those concepts I studied in the course actually are used in real world, right? So that's, and when I decided that I want to go more into data science, cloud computing side, and what better way to learn about cloud computing than AWS, the largest provider for cloud computing. So that's how I ended up in AWS after a year of working at MoneyGram, and I joined as a cloud support associate, which is a very entry-level position, and worked for about 3 years within different roles, got promoted from associate to engineer, senior engineer, and now I'm working and leading the team, as I said, of 13 engineers, right? So during those 3 years, I also gained the subject matter expertise in one of the AWS services called Amazon OpenSearch, which is, I'm going to discuss about that just in a minute, right? I know that cloud computing is booming, and most of you might already be aware of AWS, but I just want to add a couple of examples for people who have not explored AWS just yet, or maybe have not gained that much expertise, right? So everyone here watches Netflix, right? Ever wondered how Netflix has built such a robust infrastructure for excellent recommendation algorithm? Like, you watch something and they are coming up with a new suggestion, which is highly likely that you're going to like the next one too, right? So They use various AWS services like S3, which is our simple storage service, Amazon SageMaker, which is our biggest machine learning service, where my team is focused on a lot, and then AWS batch for the batch transformations, right? So any kind of use case or a problem in industry that you can think about, AWS has developed a service to make your job easier for that. So they use that Amazon SageMaker to create, train, and deploy the machine learning models in the cloud. Eventually use those technologies to see what you're seeing in the TV, right? They're implemented in a way that it has that robust, highly available model that allows you to continuously stream your favorite shows, right? Another interesting service, which I was very interested in, gained my subject matter expertise, as I said, is the Amazon OpenSearch. OpenSearch is a distributed OpenSearch search and analytics suite used for a broad set of use cases like real-time application monitoring, log analytics, or website search. So let's say you have 100 lines of logs getting generated from various applications. So when working on a bigger enterprise, like when you have different solutions developed for your use cases, you also are building that log analysis for your tool that you want to make sense out of those thousands of lines of logs that is getting generated, right? So OpenSearch allows you to do that distributed search for your logs, right? So when I joined AWS, I had limited knowledge about cloud computing, I would say, apart from some of the AWS certifications and some of the academic courses that I had learned for. So I had a very sharp learning curve when I joined AWS, but I learned things like distributed systems, ETL, or machine learning, real-time data analytics, and all the cool things about how AWS makes it all possible, whether it is Netflix or Formula One or NFL. And that's how, I transitioned through different roles from associate to engineer two, and then now a manager. So couple of things now that we all know about what is data science, what is machine learning, and you're all learning in the academic world as well about the theory part of it, right? Couple of things that I have learned during this 5 years of industry journey is that, one, there is no limit to opportunities that are available to you, right? No boundaries that can stop you from doing what you are passionate about. And the second is the way you actually grow that interest or passion is really dive deep into it. Be like, when you're taking a course in a university, for example, you're taking a machine learning course, go out of your way to know about how machine learning is actually used in real life, right? In the world of internet, there are a plethora of information available in the form of, case studies, how different industries are doing it, or how Amazon or Netflix are doing it, right? And then give yourself an independent project to gather the data, create algorithm, train the model, and see, what results you're getting. Doesn't matter what the accuracy of the model you get for the first time, but at least you are getting that exposure to how it all works in real life, how it all combines together to gather some meaningful insights out of your data, right? So I would highly encourage everyone to try that hands-on side of the things. As part of academics, we all work on the projects and, academic projects, right? That are limited to the scope of that course, right? But go extra mile to, extend that project to create something interesting on your own. And another way, I think that this was discussed a little bit before as well, that gaining the industry certifications, right? Not only the certifications help you with the job hunting or getting yourself acquainted with the technology, but it will also help you find your passion on what you are really interested towards, right? Because as we've discussed previously, right, big data or data science in itself is a huge concept. It could be that you have a lot of data and you want to store it effectively in a distributed systems where you can use Hadoop, MapReduce, Scala, Spark, Pig, Hive queries. Or you want to do data transformations or cleansing using the ETL services, or you want to completely automate and create the machine learning approach, right? So there are a lot of things that you can do in a data science, but when you really dive deep into those hands-on labs and the certification, it helps you identify which exact area of data science you are really passionate towards, and then you can start building your knowledge on top of it, and then slowly start getting your subject matter expertise, right? So opportunities are endless. You just need to identify where you want to go, right? And as I talked earlier, right, AWS provides services in every phase you can think of, every use case you can think of. So any project ideas that you have in mind, high chances that AWS already has a service which can help you achieve that use case, right? So whether it's just a sample free to your application that you want to just get started with, but I would highly encourage you to explore that side of the things, right? And my overall journey at AWS, has been a sharp learning curve, as I said. And as we say in Amazon, it's always a day one, which literally means that you are always that day one new hire who is passionate, enthusiastic about things that are happening and always eager to learn. And that's hands down my most favorite thing about working at Amazon, right? That even after becoming a subject matter expert in a certain area, I always find myself reading online blogs, going through training resources, or doing some hands-on lab myself, because AWS is so fast-paced. And again, when I say AWS, I eventually mean data science, right? It's the whole field is so fast-paced and always innovative. You need to keep up with your learning to keep up with the trend, right? And it's booming and super fast growing space, so you need to brace yourself for an incredible learning journey and always be curious to learn new technologies, right? And then just to give a quick example about Amazon SageMaker, for example, right? You might have heard about Formula One, right? So Formula One, when you see the match or a race on the TV, you cannot imagine how many things on the back end goes into a place to show you what you see on the screen, right? For example, when the race is going on, you're seeing a real-time data analysis on, hey, what are the probabilities of this driver to win, or what is the speed if they go in, they are going to win the race, or if this driver wants to win, what are the things that they can do, or how much time they can do for each lap to go there, right? Now, how is everything determined real time, right? It's just mind boggling on where all of this data is coming from, or how those derivations are coming from, right? So Formula One in a backend as well, they use a couple of AWS services, like for example, they use PostgreSQL from Amazon, as well as Amazon SageMaker, which I previously talked about for machine learning purposes. And that's where they develop their architecture using those services and are able to provide that real-time updates to the data that you are seeing on screen, right? So there are endless ways you can utilize data science, whether it is just the day-to-day purposes like COVID-19 that we talked about, to the, any new ideas. For example, a lot of startups uses AWS in their infrastructure as well, right? So as I said, whatever ideas that you are coming up with, AWS might have a solution to it, right? And I I'm speaking about AWS because I have an experience in it and I'm working on it, but I'm pretty sure that other industry cloud computing providers have the similar services as well. So don't necessarily need to be AWS, just get started with anything that makes it easier for you, and overall it helps you gain that expertise in the cloud computing area. And just to end, everyone watching this today are here because you have a great potential to bring great changes in the world and innovate some of the coolest things. So give yourself a huge pat on the back for that, but don't stop at that. Find your passion, as I said, and really invest your time and energy into it. Give it a couple of years and see what magic it brings. And overall, I have enjoyed my journey so far, and I really appreciate Dr. Khan and Dr. Bhavani to invite me here to talk about my journey. And it's been absolute pleasure to talk about my journey today. I'm happy to answer any questions, or you can connect me with on LinkedIn as well if there are any things that I can help you with, or any questions that I can help you with as well.
Thank you so much, Lipi. This was an excellent motivational talk. I have a question.
Yes.
And then once I finish the question, please wait until. Oh, there is a. Okay. Is there an echo coming? Okay, we're fine. So then Ashrafi will take a photograph. So Ashrafi, you should be motivated with Paveen and Lipi. So my question, Lipi, is I think it was really good. AWS is very, I'm quite familiar. I'm teaching a class on developing and securing the cloud and IoT. So we talk about AWS. So my question to you is, so what is the role like for data science? What are the opportunities for data scientists in AWS as well as anywhere at Amazon? That's something I'm sure those who are watching, and hopefully those who are going to watch, because once I put this on YouTube, so they will have, they could get some useful information. Yeah.
Absolutely. Yeah. So we talked about data science in various phases, right? Whether it is storing your data and, data gathering phase, or data cleansing phase, or the machine learning phase, right? At various phases, we have the roles available within Amazon, right? Amazon, as you can imagine, our biggest inspiration is our customers, right? We take inspiration from what AWS customers are asking for, and then developing based on that, right? Not only we are just coming up with innovative ideas from our developers, but at the same time from our customers as well. So when it comes to students in data science who wants to join at Amazon, again, that's why I prioritized on, hey, which field are you passionate about, right? Whether let's just take an example about machine learning. Anyone who is motivated and passionate about machine learning, Amazon is always innovative on creating AWS services focused on whatever the use case for customer is, right? For example, we have certain AWS services for face recognition, voice recognition, text recognition, right? Those all artificial intelligence, machine learning services. Now, when you are studying in data science, that helps you innovate and come up with those ideas that are currently available to AWS customers, right? When you think about AWS SageMaker, it might just be that one customer asking for something there, hey, I don't need to manage my own infrastructure. Could you come up with something there? I just have to, upload my data, and then you guys do the magic, and then I can make sense out of my data, right? And that's where the data scientists at Amazon, they page train and they created Amazon SageMaker. So that's where, any data science field that the students are motivated towards, we will have the opportunity to develop and innovate on those fields.
That is excellent. So anyone who's listening or who will be listening, so please pay attention, right? Amazon, I think, is the largest, one of the largest companies and the most, my understanding, one of the most profitable companies in the world and great place to work. And so, and very, very honored to have Lippy give this presentation. Thank you. And we are going to, and please wait until we are going to do an applause. So, Ashrafi, could you please, Dr. Khan, could you please take a photograph? Snapshot. When I say a snapshot, screenshot.
Professor, I already took one. So.
Yeah, and Dr. Khan, are you going to take one? Yeah, I think he has to go for a class too, I think, right, Dr. Khan? So Ashrafi, you have taken, here's 11 o'clock, yeah, here's a class. So Ashrafi, okay, you sent the file, okay. Thank you very much, great. And now what we are going to do, so I'm going to stop clapping now. Okay, so now it's Ashrafi, your turn, our student, right?
Yes, Professor.
Yeah. So very pleased to introduce Miss Ashrafi Akbar Khandaka. She's a joint PhD student. She works at the intersection of data science and cybersecurity. She works with Dr. Latifah Khan and myself. We are both joint advisors, and she's doing extremely well. She's finished all her qualifying, all those exams, and now she's intensely focusing on research. She's also a best female PhD student because she helps us with a lot of activities such as this event, putting together the flyer and creating websites for me. So I'm very grateful to have Ashrafi as my student. So Ashrafi, I think she, she's a computer scientist, and now hopefully with data science, who knows, Ashrafi, you may end up at Amazon, right? Or AT&T. So it's always good to have these connections with Dr. Parveen and Miss Lippy. Okay, Ashrafi, now it's all yours. Please give your presentation, and then after that I will talk, and that's the end of our program.
Thank you, Professor, for the floor.
So we are running about 10 minutes late, Ashrafi. So you have, so you have another 10 minutes, right?
Yes, Professor. So hello, everyone. I'm very thankful to my supervisors, Dr. Latifah Khan and Dr. Bhavani Thurasingham, for giving me this opportunity to talk in such a prestigious platform. And I'm already motivated by the talks that already the outstanding working women in data science gave us today. And I hope that I will make that learning work in my life afterwards so that I can be a good data scientist, obviously. So a little bit about myself is that, I am a PhD student at UT Dallas. I joined as a PhD student here in fall 2019. So it's my third year now. And I did my undergrad from Bangladesh University of Engineering and Technology. And I graduated back in 2017. So actually, considering the cultural perspective from my country, it's not easy for a woman to choose engineering study or background as to go forward in life. But my family and my surroundings was really supportive for me to make that decision for me. And afterwards, I also decided for my graduate studies, and I came here in the United States. So a bit about like how I was motivated about working in this particular areas is that when I was applying for the universities, and also when I was working after I graduated from my undergrad program, like I was working with one of my professors from my undergrad university on Mimic3 dataset that actually is a very well-known public dataset that works with health data. And we were working on mortality prediction. And there was another work which actually awestruck me, honestly speaking, like using human factors in computation. So I was like, wow, people can use data for even for modeling human behaviors and all. How people can, affect other people as well with their communication skills, and how do they interact with others. And that can be a model using some mathematical models or computation like that. So that actually drawn me into this area mostly, I would say. And obviously, after coming to this wonderful university and the surroundings are here, my professors and also the courses that I took, those actually also inspired me a lot for pursuing a career in the specific domain. And as Professor Bhavani said, I work in the intersection of data science and cybersecurity. So most of my research is concerned about how can we use the different models which are like language model or maybe machine learning models to solve the problems in cybersecurity domain. So right now I'll just talk about a bit about what my present research focuses are. So what I do have, my first project is about like how can we help the security analyst to take a decision when they are actually have found some attack ongoing in some infrastructure or a system, so that what kind of defensive measures or countermeasure solutions they can actually apply and solve that problem just within a short amount of time. So what happens is that, like as Dr. Jennifer Holmes in the first talk said, like there are policies, but there are solutions. If you cannot just use it in the appropriate scenario, then it's actually of no use. So as I said, like whether there is a solution existing for a certain problem, it's not actually it's obviously important, but also it is also important that the proper measure is taken in the proper amount of time, because we know that cybersecurity is a very fast problem in the present world, and obviously like prompt action based on some attack ongoing is really important, so that not any kind of damage is done in the system or for the enterprises. So that's why what we're trying to do is that how can we automate association of the knowledges in the cybersecurity domain, the attack scratch the attack surface, and also the defensive solutions provided by different scientists or like different enterprise solutions, and how we can use those knowledge to recommend the cyber analyst about what decisions or what measures to take at what certain point. So that's one work that I'm focusing on right now, and there is another work that we are doing is that is also with another professor's lab students, like Dr. Kevin Hamlin is a professor at UT Dallas, and we are also collaborating with his lab students. So that is that project is about finding vulnerable functions within a large enterprise or like industry products. So like let's say even if we Google about a certain application and about the certain application development in Google, even if we also look at the repositories like GitHub or something like that, we can see that even a simple program, a simple maybe app like just an app which just provides some office tools like features to the users of that application, that can be also like thousands of lines of codes, and that can have like thousands of functions or at least hundreds of functions. So what the problem is that whenever a software patcher or a software engineer is trying to find vulnerable functions within that program, so they have to actually maybe analyze each of them individually. So that's obviously tiresome and excruciating, and that's also not effective if you want to patch the vulnerabilities within a short amount of time and with limited program coverage. So what this work intends to do is that how can we rank the vulnerable functions within a very large production or production software, that so that the patcher has to just look into a specific amount of functions to take care of all the existing vulnerabilities in that application itself. So it's obviously important that the people who are actually working in the software engineering research industry, or maybe also about debugging or something like that, they know that representation is a very important thing for working in the data sector of programs like this. So what our work focuses is on how to represent well the code so that the information can be well used with the existing machine learning models. Maybe it can be graph-based learning or any other machine learning model which are existing. But the representation and the notion is important. Like obviously, as most of the talkers actually say today, that like the essence of data can only be used when it's understood well and represented well, obviously. So our work focuses on that, and yeah, we want to make this thing less tiresome. The whole point of data science is to automate things, as also Dr. Sanda said, like ACM is looking forward to automating data science because we want things to be done automatically. Obviously, for that, we have to represent and understand the data well, so that like how rationality can be used for solving such kind of problems. So that's about it, like for my present work. And I would like to say that obviously my future goals are to leave some tangible effects in the research community. Hopefully I can do that. I'll have to work hard on that, obviously. And yeah, I mean, I'm so motivated by today's talks. And one thing I would like to do in my later part of graduate studies, or maybe if I pursue some post graduations as well, is that what I was intrigued about in the initial journey of my mind towards graduate studies is that, like, how can we use or incorporate human factors in computation so that, I mean, rationality can be well understood and can be applied for solving different problems. Like, because I think for automation of data science, I believe that it's important how, like, we make the decision based on some structural information. Like when a piece of information is structured in a well-mannered way, then I think it's pretty much understandable for people to how to work on it, how to make a decision based on that. So I would like to study those factors so that, like, it can help further data science to empower things for solving integrate problems. So yeah, I'm very thankful again for working with these two wonderful people at UTD, and I really look forward to learn a lot from them as well as my other peers in my life, so that I can at least make some, I mean, differences in the field of data science and cybersecurity. Thank you for listening to me, and I hope to learn more from you people.
Thank you so much, Ashrafi. That was a very inspirational talk and motivational and as well as technical. So I'm really pleased that you are part of our team, and very honored too to have you as part of our team, Dr. Khan and myself. So I think what I would like to do, I think Dr. Khan has left. So if Ms. Rhonda is there, and if you can take a photo of a snapshot of all of us. So maybe if you can take it too, Ashrafi, since you are taking the photographs. Okay.
Yes, Professor, I've taken it.
Okay, thank you so much. And this has been a good talk. So I have a question for you before I start my talk. I'll try to finish mine at 10:40, and so then we can start playing the, anyone can watch. I can, I'll play the Stanford video, and then anyone can watch that. Okay, so my question to you is, how would you inspire, I know you've already done that, a student, right, to work in data science? What are the benefits and so on? So what do you think?
So I think, Professor, as I think Dr. Pallavi Parveen showed the Venn diagram of data science. So actually, I think like anybody with different technical expertise can work in this field actually, because there are certain problems, like, let's say even in the domain of political science or maybe policymakers, and also like social media is like also even like what kind of technology should be available to the children. Those kind of problems are also being solved right now using data science and language modeling and machine learning modeling. So what I believe is that, like, it's very much easier and motivational to incorporate whatever a field a person is trying to pursue, to mingle it with the data science field. So, and that way it also gets interesting, and like the people, wonderful people around the world, they're actually very helping towards the women to the women community, actually, I'd say, to leave a contributional remarks behind while working in this domain. So they can actually easily pursue this as a career or a career path, or like, as a part of passion as well. As I said, even if you are deviating a bit from basically computer science or something like that, even behavioral science or maybe cognition science, those can be very much interrelated to this data science part. So data is everything. Like when I was interning back in Bangladesh for like business, I was working as a business intern in Microsoft that time. So the MD actually said that data is the new currency. So I actually believe that still now. So data is everything nowadays. Even every sector, just every sector.
And it's a very I'm glad you are saying that, because that's what I'm going to my talk is going to start with that when I give my sort of closing address. Data is everywhere. That's great.
Yeah.
So okay, I'd like to give an applause for you. Let's see how we do that. And okay, so anything else you want to add? Otherwise, I'll go on with my talk.
Thank you so much for the floor.
Thank you. And remember, we have a deadline coming for your paper, the IEEE Big Data Security and Privacy. So that's for a paper for that for you, okay?
Yes, Professor.
So thank you very much, Ashrafi. So now I'm going to share my screen, and let's see. I just hope that when I share my screen that it's still going to get recorded. Okay, it's still recording, isn't it? Is it recording still? Yes, good. So, okay, so my talk, and remember, we are celebrating International Women's Day tomorrow, I think. So we have some great things going. We have got the WiDS going on, global WiDS in San Francisco, Palo Alto at Stanford. We are having our local WiDS at UT Dallas and WiDS everywhere. So this is the last presentation, and then as soon as this is over, we are going to make main stage, and I'm going to have it. Okay, let me finish my talk first. So my talk is going to be why a career in data science for a woman, and very briefly some of the research that I'm doing with Dr. Khan and Dr. Murat Kantajulu on integrating data science and cybersecurity. Some very brief charts, about 10 charts, but let's focus first on why a career. What is unique about data science as opposed to other areas in engineering and computer science? So as Ashrafi mentioned, every application needs to process data. As they say, data is here, data is there, data is everywhere. And one of my colleagues at the National Science Foundation, former colleagues, she used to say, data makes the world go round. And as Ashrafi mentioned, data is in healthcare, medicine, engineering, social science, finance, brain science, and even cybersecurity. The whole area of informatics, right, deals with data in a number of applications: bioinformatics, financial informatics, social informatics, engineering informatics, healthcare informatics, medical informatics, cybersecurity informatics, brain informatics. So it's one of the most lucrative fields in STEM with high income. Data science researchers and developers are in great demand, as we have heard from Dr. Parveen and Ms. Lippi. There's substantial, whether it's government, academia, industry, substantial funding with many agencies in research and education, and this trend is expected to grow. And women still make, the numbers vary. In some areas, it's less than 10%, like cybersecurity. Data science is around 20-25%, not more than that. Still, we are vastly underrepresented. And data science helps humanity. It's actually social good. Let me correct it, not social goof. Sorry about that for the spelling. It's social good. Usually I won't correct it, but I don't want anyone to think it's social goof. It's an intellectually challenging field. And so that's what's unique. What the 10 reasons? I think I've given more reasons. Given the opportunity, I think women can excel in any STEM field, including data science as men. In some areas, actually, women do even better, right? Data, especially I would say in areas like data science, women have a lot of opportunities. Data science is very exciting field with so many innovations and developments happening so rapidly. As we said, Ashrafi and I and everyone else, you can integrate with even arts and humanities, natural science, social science, whatever. IoT, data science has many options, from research to academia to product development and so on. And millennial and startups also, millennial women and beyond, have the flexibility and freedom to choose careers and have female role models in the field that us baby boomers never had. In many research areas, you can work from home most days, making it ideal for women to have a familiar career. But although after the pandemic, many of us, data science or not, we are working at home. But one of the things is that we especially if you are working, especially in pure data science oriented fields, because we don't have labs to go to, right? Because when you have chemistry labs and biology labs and physics labs, you can't do them at home. That's what I was meaning. Okay, continuing. Many data science jobs cannot be overtaken by robots, right? We need researchers and developers to collect and analyze massive amounts of data, such as from the IoT systems. Data science is a highly paid field with numerous job opportunities. Why not women take advantage of these benefits, right? And more importantly for women, we can be financially independent with a career in data science. And financial independence, it means self-respect, less stress and confidence. And I always tell, to all the talks I give to women. Having financial independence is a must for every woman, especially when it comes to personal relationships, right? So let's say you are married, and hopefully many of us will have, or will have husbands who are really good men, but sometimes we hear about, abuse and so on, women, spousal abuse, especially happening more to women. But if the woman has financial independence, she can walk out any time. She can choose to stay in the marriage. I'm not advising all the women to walk out, but it's a choice. That's what I'm stressing. And financial independence is very important. Data is everywhere, as again Ashrafi has said, north, south, east to west. Therefore, such massive amounts of data has to be analyzed to extract the nuggets. You can make the world a better and safer place with data science, and including addressing the major problem that we are faced with, violence against women and children. There is with technology, there's this whole area of data science for good. We can do analytics to look at emotions about children and women and analyze them. Are they going to be, are they being abused? But again, we have to be careful about false positives, false negatives. We don't want to go and charge people that they are abusing women and children. We are going to be careful. So we've got to use data science in a fair manner, and also ethics is really important there. Finally, advice to all women: do not be undermined by others when they say women are not good in STEM. Never give up even when women put you down. Work hard, set goals, be flexible as life does not turn out the way we want it to be, especially when you have married children. You've got sacrifices that you have to make. Love your work, but also enjoy life. Be a role model to the younger women and learn from the successful women. Even though you may get into administration, which is very important to support women, because remember, only when you have more department heads, women, you have a chance of becoming a dean, right? We are very fortunate at UT Dallas. We have now a female dean and a female provost. That's the first time it's happened. I've been here for 17 years. Only the last few years, we've had that honor. Even so, what I'm saying is, but still, it's important to keep yourself technical and continue to do top quality research and development. And don't forget, get a mentor to help you along the way. Mentoring, I benefited a lot by having mentors. For senior women, support women on issues, some advice on issues of importance. There are tenure-related matters, promotions, corporate boards in the industry. Connect women technologies with senior personnel, both men and women. Mentor women and give advice on career development. Promote women for program committees, program chairs, awards and fellowships like ACM IEEE Fellow. Venture funding, again, what I'm hearing, there seems to be a little bit of discrimination because a lot of the venture funding is going to men. Promote women, as I said, to take on administrative jobs, very important, so that they can mentor the junior technologies, right? Only if we have, say, as I said, more women department heads, they can be division directors, vice presidents, and president. Introduce data science in elementary, junior, and senior high schools at a very young age. And of course, who can forget Hedy Lamarr? She was not really a data scientist, but she was really a technologist. She was Hollywood's one of the most beautiful women. If you see Hollywood's beautiful women in the list, you will see Hedy Lamarr. And she's also brilliant. Why? Because she's the one who invented Wi-Fi and she made her technology in the 1940s, and a patent has made Wi-Fi and Bluetooth possible for us. And as a result, we can develop techniques to analyze all of these Wi-Fi data, sensor data. Okay, so with that, I finished the first part of the presentation. I'd just like to take no more than another 5 to 7 minutes to talk about some of the work that I'm doing in our team, integrating data science and cybersecurity, and also applying Internet of Transportation. And as I said, we have been doing some work on privacy-aware quantified self. What is quantified self? We are carrying our mobile phones all over the place, right? And information is being collected, Fitbits and our glucose monitoring. But there is this quantified self movement, which is sociologists and psychologists. They are looking at collecting lots of information about us to give us advice. Like, I love vanilla ice cream and milk chocolates. If I open the refrigerator to eat milk chocolates, wouldn't it be great if a message is sent to me directly, like a voice, or on my smartphone and says it's not good for you, right? So without a doubt, quantified self is very important. But imagine all this information being collected, and each time, because by the way, I try best to not to have vanilla ice cream and milk chocolates, but let's say somebody takes photographs and sends it to my insurance company, and that's not good for us. So such data collection, sharing, right, can be used without the consent of the individuals. For example, data collected by a device monitoring glucose, people can use it to send it to the insurance companies, and not only will it discriminate, say, if I have high blood sugar myself, but also my son and my grandchildren. So my privacy is essentially violated, right? So it can aggregate information from Facebook and Twitter and my purchase patterns, and complete profiles can be made. So what I'm saying is, while data science, machine learning is crucial for all these applications, there's also a privacy element. And we are working, Dr. Murad Kantajulu is one of the top experts in data privacy, okay? So what are we saying? Briefly, we are saying every step of the way, we need policies for data collection, data storage, data analytics, data sharing. So in our architecture, we have health information, fitness data, location, social media, and so on. Everything is being collected and analyzed. All of the information can't be in our smartphone because it's really not enough storage. So some of them go into the cloud encrypted, some through anonymized services. Again, AWS we can use to collect the data in the cloud. And so privacy, we are policy based. This is what we have developed. And again, policies have to govern. And that's why if you had listened to my question to Dr. Holmes, I'm asking what are these policies? Because we computer scientists, we come up with very toy policies, TOY, like saying, oh, I will tell a secret to Parveen, provided she doesn't tell that secret to Ashrafi, right? That's a very childish policy. So realistic policies, we are working with experts like Jennifer. Okay, the next is joint work with Dr. Khan. He's like a leading expert on data science for cybersecurity applications. Number of papers, we have written a book, 2 books actually, on this particular topic. We have just finished the 3rd book. So essentially using past data to build classification models, predicting the labels of future instances, and help decision making. So you could ask the question, what is the big deal, right? We've been doing that for 20 years. The big deal here is massive amounts of data, data stream, continuous flow of data, very large, and it's very common in our digital world, massive amounts. So when you have continuous data coming, the concepts are changing. Yesterday it's Amazon. Today it could be buy Amazon stocks. Today it could be buy Microsoft. Tomorrow Google. Next day Facebook/Meta or whatever they call themselves. And the next day Twitter maybe, and Microsoft and all the Apple and all these companies continuously changing. So what Dr. Khan has come up with some of his students, as well as Professor Hahn, top-notch data scientist in the world from Urbana-Champaign, developing an ensemble of models. These models are changing, right? One day it'll say by Microsoft, next day something else. These concepts are changing. So we've developed an ensemble of models, finite number. So we throw away the models that are not, that are out of date, right? And that could be expert. And then the models are developed, throwing away the bad models, and the new data comes in. If it's attacked, then block and quarantine, otherwise it goes to the server. Okay, so that's the ensemble based. And guess what? This is Dr. Parveen's PhD thesis. So we developed this ensemble of models and applied this to her PhD work on insider threat. Insider threat means bad people pretending to be good people, right, in an organization. So for example, you have some bad persons. So it could be processes, bad processes. So it could be like an email process, a database process. They seem to be like innocuous good processes, but they could be malicious, right? So you can't detect. So they are typing all kinds of stuff, system calls, you take chunks, and then we develop this extract features. We apply unsupervised and supervised. Some of the unsupervised algorithms Parveen developed. Some of our earlier papers are here. So we build an ensemble of models, and then when test data comes in, extracting features and then we test, and is it anomaly or not? So this is really, especially at that time, the mid-2000s, it was really highly original work, and a lot of others have referenced our work, and the field has advanced. Insider threat is a very challenging problem. Now I go on to my joint work with Dr. Murat Kantarjulu, and how do you secure data science machine learning? Remember, these machine learning techniques could be attacked, and what all of us have said this morning, machine learning is crucial, right? For data science, for applications like healthcare, for finance, for everything. But if these machine learning techniques are attacked, instead of, say, buying maybe Amazon stock, it's giving us wrong information and telling us to buy IBM stock or something like that, right? So, and imagine for healthcare applications, it could, cost lives of patients. So what do we mean by that? The machine learning, the adversary is watching. He or she is watching what data we are using to train our models, and what is the model that we are using. So that is adversarial, understanding adversarial learning. What is the adversary learning, right? It's not concept drift. It's not online. Adversary adapts to being detected. It could happen during training, test time, and so on. So adversary is modifying our data and defeating our machine learning algorithms, right? It's a game that is being played. So this is our original support vector machine. This is a support vector machine boundary. Bad instances, red squares. Blue circles are good instances. And look what the adversary is doing. Learning and pushing 1, 2, 3, 4, 5 bad instances into the good instance space. And if one bad instance could create a lot of problems. So what do we do, right? So we come up with adversarial machine support vector machine. So what we do is, here is the original adversary. Black dash is a standard support vector machine. The red crosses are bad. The green circles are good. So in here, the red crosses here are not caught because adversary has pushed. What do? We are playing games with the adversary. So again, threat model, test deployment time, attacker modifies X to X prime, modified packet length, you can add dummy bytes, good word to spam email, add noise to an image. And so what we are doing, playing games, and then trying to move the support vector machine boundary here. So by the blue line is the adversarial support vector machine boundary. The challenge is to move this at the appropriate place that can catch as many bad instances as possible. So by moving this, all of these bad instances are now caught. Now you can ask a question. What about moving this thing right here, the blue line? Then all the bad instances will be caught. But imagine if you move the blue line here, the green circles will show up as bad instances, right? Sorry. The green circles below the blue line will show as bad instances. So we are going to get false positives. So that's where we can't move the blue line right here. We have to find the appropriate place to catch as many bad instances as possible without having false positives or false negatives and high accuracy. So that's the challenge. Okay, now just last couple of charts. We go into Internet of Transportation, right? Internet of Things we know. And again, thanks to the beautiful and brilliant Hedy Lamarr, we have got now IoT systems like our coffee machine or tea machines talking to clocks and televisions and shopping information, our smartphones, everything talking to each other. Similarly, Internet of Transportation, it's a lot of companies are investing autonomous vehicles, right? So we want vehicles to be as autonomous as possible, but then the cars are talking to trains, talking to trucks, and talking to roadworks, and everybody communicating. So that why? Because we can have safer roads, better driving experience, and so on. But major problem of adopting this is security and to some extent privacy. So what did we do for security? We came up, and that's with Dr. Alvaro Cardenas and our joint PhD student, Dr. Raul Quinenes and Professor Cardenas. So we developed a physics-based anomaly detector. Dr. Cardenas is a control systems expert, control and security, cyber physical systems. So the challenge is to come up with this physical model. The actual physical model with using nonlinear models, well-known nonlinear models, we were focusing, there's, autonomous vehicles are aerial, sea, and ground. Aerial could be drones, right? So we focus, and airplanes, sea is ships and submarines, and ground, of course, trucks, trains, and cars, and so on. So we focused on aerial drones and ground cars. And so we are modeling this with lots of differential equations here, accelerometer, gyroscope, and magnetometer sensor data X, Y, Z, Z-axis for the aerial and vehicle positioning and steering for the ground vehicle. So what are our algorithms? We used extended Kalman filter. Initially, we didn't use a sophisticated machine learning. It's used to predict AV's physical behavior by estimating unknown parameters from noisy sensor data. Algorithm is divided into two sections. It predicts and corrects the estimation before it is compared against the sensor data. For anomaly, we use CUSU and KUSUM algorithm is then used to detect persistent attacks. An alarm is raised if the residual difference is larger than a predefined threshold. So in my longer version of this presentation, I talk about our implementation and some of the results and some of the drones and cars that we used in the implementation, but you get the picture. We haven't used machine learning yet. So privacy, we haven't really done work on privacy, but without a doubt, privacy is important. I don't want people to collect data about me. Let's say I'm smoking in the car. Of course, some people will say when you are smoking, when you're out in public, forget about it, or my location or some information, right? So there's a lot of discussion about privacy. By the way, I don't smoke. But anyway, so we have this car, just like I talked about the smartphone. We have a small gadget that collects data, storage, analytics, and sharing, and we have cloud for the other longer term data. And then anonymized data goes to cloud services. Through cloud services, we access the cloud storage, maybe AWS, but the data, instead of healthcare, social media, we get radar, GPS, camera, LIDAR, and ultrasonic sensors. And again, we are saying policies. Policies have to guide data collection. How long do you want to keep the data? How are you going to use the data for storage, analytics, and sharing? Okay. So my last chart, summary and directions, without a doubt, development, when I say SecAI, it's security and AI, integrating cybersecurity and AI like data science, ML exploding, applications of data science for security, or AI for security inside it. So I'm using the word AI, ML, data science interchangeably. Insider threat detection and security for AI, adversarial machine learning, developments in privacy aware healthcare, managing one's life cycle. At the same time, with the development of IoT, we have privacy solutions being developed mainly, and also security solutions, physics-based. And as driverless cars become a reality, we'll have to depend more and more on machine learning. Without a doubt, machine learning is being applied for many, many Internet of Transportation applications. But the question, again, what happens if these machine learning techniques are attacked? Big problem. And what about privacy, right? More machine learning we are using, it can gather all the information, data, and privacy could be violated because we can have collections of data lots of data being collected. And the question is, how can we do trustworthy analytics? Some people have said, can we apply formal methods for analyzing machine learning systems? And as I said, numerous opportunities for substantial research. And some of the things I mentioned, Dr. Alvaro, Dr. Murad, Dr. Latifah, Dr. Raul, and Rhonda Walls, and hopefully I can add Dr. Ashrafi because she's starting to publish papers. Oh, and also I've got to say Dr. Parveen, I'm talking about her work as well. And so a lot of people, a lot of our students, his entire team contributed to some of the work that I've discussed. So I'm going to now stop sharing my screen. Okay. Okay, so that finishes my presentation, and time-wise we are perfect. So I'm going to now start sharing, trying to join the Stanford. Ashrafi, if you can take a photograph of this. I know I've been on every photograph, but if you can take a photograph, please, if you are there, Ashrafi.
Yes, sure.
Thank you.
Yes, Professor.
Thank you. Okay, this concludes our session, and I'm going to go right away. Anyone can join and watch. The Stanford event is going on till about 9 o'clock our time. So I'm going to keep it on till about 3 o'clock our time. And then this will give you sort of motivation what they are doing at Stanford. And then we can, thank you so much to all those who attended, all those who are going to be listening, and then also to everyone here, and also our speakers, including Ms. Lippy, Dr. Jennifer, Dr. Pallavi Parveen, and let's see, Ashrafi, thank everyone, Rhonda Walls and Dr. Khan, for co-organizing this with me. So let's see how I can, I need to share my screen for that.
I just came to the campus, so I was not in the meeting for a while, for half an hour.
No, I know you've got to start teaching.
Sure.
Yeah, so let's see, just a second. I want to go in here. And where are we now with respect to, just a minute, I'm going to go, I got all these things. Okay, let's see whether I want to join. Okay, let me close this one and let's see. Okay, main stage. Apparently we can join the main stage. A keynote address from Cecilia Arrogance. So we have gone to main stage. Okay, and I'm okay. I'm going to share my screen now. Okay, everyone. So this is for Stanford. We are joining Stanford. I'm going to leave it on till about 3, whatever time. Sometimes my internet might go down, but I'm going to leave it on. Okay, so please watch as much as you can. Okay, thank you so much, everyone. Okay, we finish and listen to Stanford, okay? By the way, I'm stopping. I'm going to stop the recording. Okay, I'm going to stop the recording. I can't record the Stanford thing. So I'm going to stop our recording, okay? But y'all can watch. I'm going to stop the recording.